trying to keep up with all the tech and new ideas in city development, wow, it can feel like chasing a signal that keeps fading, right?
Uh-huh. It moves fast.
Exactly. That's why we're doing a deep dive today into CommuniCity. It's a big project aiming for innovative solutions responding to the needs of cities and communities.
Boy.
Think of this as your shortcut, to getting the inside track on what this initiative is actually all about.
Absolutely. And at its heart, CommuniCity is really looking to make it easier for developers, people like you listening, to create new solutions for our cities.
Okay.
It's setting out to do this by providing some, well, fundamental pieces, common ways of doing things, specs, software tools you can actually use, and even places to test your ideas out. The big win they're aiming for is that these solutions should, ideally, be able to work across different cities without a major headache. Interoperability. Creating a real ecosystem of urban technology that actually talks to each other.
So it's trying to build a kind of common language for smart city tech.
Pretty much, yeah. That's a good way to put it.
Okay. So for this deep dive, we're looking at excerpts from their D4.1 Technical Architecture and APIs. Sounds official.
It is. It's kind of the blueprint.
Right. The project's blueprint and instruction manual. It looks pretty detailed, but our mission here is simple, right? We want to pull out the most important technical bits of CommuniCity for you.
And see how it plans to spark innovation, actual innovation, in our cities.
Okay, let's unpack this then. Where do we even start with the technical groundwork?
Well, a really important starting point is this idea of minimal interoperability mechanisms, MIMs. They come from OASC, the Open Agile Smart Cities Initiative.
MIMs. Got it.
These MIMs are kind of the core philosophy guiding this whole project.
Okay, MIMs. So in simple terms, what are they trying to achieve? Like, what's the goal?
Think of them as vendor neutral and technology agnostic blueprints. That's key. They're for making different systems and data sources understand each other. So whether we're talking about data itself or whole systems or specific services, MIMs want to create a sort of level playing field.
A level playing field. I like that.
Where cities and the companies offering solutions can connect more easily. The OASC network is actually a big deal in this space, really focused on making digital transformation happen in cities, practically. Implementation driven.
Practical is good. So these aren't just floating ideas. Which MIMs are most important for CommuniCity? What does the document say?
Right, they're not just theory. The document highlights 5 that are quite developed and really relevant here. First up, there's MIM1.
Okay, MIM1.
It's all about managing context information. Now imagine every sensor, every system in a city speaking a different language. It's chaos.
Oh, yeah, total chaos.
So MIM1 aims to create a kind of universal translator for urban data. It provides a single uniform way to access and share data from all sorts of sources, IoT devices, other databases, you name it.
Through a common interface.
Exactly.
Yeah.
This could really cut down on the complexity and, frankly, the cost of integrating different smart city solutions.
A single window for all that city data.
Yeah, that sounds like it could unlock a lot. Okay, what's next? MIM2.
Then we have MIM2. This one focuses on common data models across different sectors.
Common data models, like standard definitions.
Precisely. Think of it as agreeing on the basic structure and meaning of data. So it's easier for applications and systems to understand and exchange information, whether it's smart cities, agri-food, utilities, industry. Doesn't matter.
So no more data speaking completely different dialects, basically.
Exactly. Trying to break down those silos where data can't communicate effectively.
Makes sense. MIM3.
MIM3 is about ecosystem transactions management. Okay, this sounds a bit businessy, but it sets up a framework.
A framework for
data and service providers to offer what they have, data, processing, whatever, with clear terms and conditions. And on the flip side, for consumers like developers or other city departments to easily find and access them. Ah, okay. So it's like setting up a marketplace almost for urban data and services.
Yeah, you can think of it like that, a regulated marketplace.
Interesting. An app store, but for citywide solutions?
Maybe.
And MIM4 and MIM5, quickly.
Sure. MIM4 deals with personal data management, giving individuals, actual control over how their data is shared. Transparency is key there.
Right. Important.
And finally, MIM5 addresses the growing area of algorithmic systems compliance. Things like fairness, trustworthiness, transparency for AI used in cities. That's a big one.
Yeah, huge. So CommuniCity isn't just grabbing these MIMs off the shelf, are they? They plan to contribute back.
Exactly right. The project wants to not only use these existing tools, but also help refine them based on what they learn what the participating cities actually need. It's a two-way street.
Okay, so MIMs are the foundation. But the document also mentions some earlier projects, right? Things that helped pave the way. Let's talk about SynchroniCity.
Yeah, SynchroniCity was a really important early effort. It was trying to create a single digital city market in Europe. Big ambition.
Single digital city market.
They tested this out in several cities across Europe, even globally, actually. Lots of different partners involved. The main idea was to build a consistent environment specifically for smart city solutions powered by the Internet of Things, by IoT.
And it also introduced this idea of interoperability points. That term sounds significant.
It is, yes. SynchroniCity identified these as the key spots where different systems needed to be able to connect and share information reliably.
Okay.
They defined a basic structure, a logical architecture with things like context data management, IoT management, data storage management, even an IoT data marketplace. And also, importantly, considerations for security, privacy, governance, and, just keeping an eye on the platform itself, the monitoring.
So these components were like early prototypes for the more standardized MIMs we just talked about, kind of precursors.
Precisely. Yeah, you can see the lineage.
Yeah.
SynchroniCity also highlighted the importance of what he calls southbound interfaces.
Southbound, meaning?
The connections down to the actual data sources, the sensors, the IoT devices on the street, and northbound interfaces.
Going up to the apps.
Exactly. Letting the apps that people actually use interact with the platform. And importantly, SynchroniCity also provided open source examples, reference implementations of how their system could be built.
Open source is always a good sign. Means more people can build on it, learn from it.
Absolutely.
The document also mentions FIWARE quite a bit. What role does that play? Sounds like another platform.
FIWARE is another key piece. It's an open source platform designed specifically to give developers the software building blocks, they call them generic enablers, that they need for all sorts of smart applications, including, of course, smart cities.
Generic enablers, like reusable components.
Exactly. They help with things like getting data from different places, making it consistent, harmonizing it through a central component called a context broker.
The context broker, like a central hub.
Yeah, think of the context broker as the central point where all the different pieces of information get organized and made available.
Harmonizing data. Yeah, that sounds like a recurring theme, a problem that keeps coming up.
It's fundamental.
And this context broker uses a REST API for applications to get the data. Can you explain REST API simply?
Sure. Imagine you're in a restaurant. You, the application, give the waiter an order that's the REST API call, asking for specific information like what's the current traffic status. The waiter, the API, goes to the kitchen, gets the info, and brings it back to you in a standard, easy-to-understand format, usually JSON.
Got it, like ordering data off a menu, very clear. And FIWARE offers a whole suite of these waiters, these generic enablers, for different tasks.
Exactly. FIWARE has a pretty wide range of these generic enablers. They cover things like connecting to IoT devices, managing the flow of that context data, and then also processing, analyzing, even visualizing that information.
And it's used quite a bit. It's not just theoretical.
Oh, yeah, it is. FIWARE components have been used in many smart city projects around the world. They've been pretty thoroughly tested in research and pilots. And importantly, some of FIWARE's stable ways of doing things, their implementations, line up really well with certain MIMs.
Connection back to the MIMs.
Yes, particularly the NGSI-LD API, which aligns with MIM1. We'll probably dig into that a bit more.
Okay, definitely. So we've got MIMs giving us the overall rules, SynchroniCity offering an initial model, and FIWARE providing some of the actual tools, the building blocks. What about this Smart Data Model Initiative? What's that add?
Right, the Smart Data Models Initiative. This is a collaborative effort, a team effort involving key organizations like the FIWARE Foundation, IUDX, TM Forum, and OASC itself.
The MIM people.
Exactly. Their goal is to further improve how different systems can work together by creating and promoting shared, standard ways of describing data. Standard data models.
So like common dictionary for data, but across different industries.
Precisely. The aim is to create a widely accepted de facto standard for data interoperability, used across many different sectors, not just smart cities.
Okay.
To do this, they develop and maintain a really big collection of open data models. For areas like smart cities, yes, but also agriculture, water, energy, logistics. You name it.
And these data models have specific qualities, I assume. They're not just thrown together.
No, definitely not. They're designed to be flexible, adaptable, easy to extend. They're well documented so everyone can understand them. They're based on best practices and open standards. And crucially, They're supported by a strong community to keep them evolving and improving.
So CommuniCity gets a huge library of existing vetted data models to work with. They don't have to reinvent the wheel for describing, say, a parking spot.
Exactly. Saves a huge amount of effort and promotes consistency right from the start.
This all sounds like a really coordinated effort, building a more standardized, connected, smart city world. So how does CommuniCity itself fit into this picture? What's its own architecture look like at a high level?
Okay, so CommuniCity's main design, its architecture, can basically be broken down into three key parts, three logical components. You've got the CommuniCity specifications, the Toolbox, and the Sandbox.
Specs, toolbox, sandbox. Okay, like building blocks that fit together?
Yeah, it's a good way to think about it.
Specifications first, then the tools, then a place to experiment. Tell me more about these specifications. What are they?
So these specifications are like the common rulebook, and they also define the basic components, the building blocks, that developers will use when building applications for the project's pilot cities.
The rulebook. Okay.
And they're heavily based on those OASC MIMs we talked about earlier. Initially, MIM1, MIM2, and MIM3 are considered mandatory specifications for the pilots.
So these are the guidelines, the minimum requirements almost, that developers within the CommuniCity project need to follow.
Exactly. But it's important to note, these specifications aren't set in stone. They're expected to evolve based on what the pilot projects actually need and the feedback from both the cities and the developers involved.
A living set of standards that can adapt. Sensible.
Yeah, and CommuniCity also plans to help develop other MIMs too, like MIM4 for personal data, and especially MIM5, which deals with making sure AI is fair and transparent. They want to be part of shaping that.
Okay, that makes sense. Now, what about this toolbox? That sounds, well, useful.
The toolbox is where things get practical, really hands-on. It contains the actual software components and services that CommuniCity will provide to developers who participate in their open calls for pilot projects.
Okay, actual code and services.
Yes. This includes things like open source software that shows how to implement the MIMS reference implementations. It also includes those open data models we discussed from the Smart Data Models initiative. Both of these will be available in the project's online repository, like on Git.
Real, usable tools that developers can get their hands on, not just documents.
Right. And importantly, it also includes software as a service, SaaS, things like AI algorithms that developers can access online.
Through web apps or?
Through web apps, yes, or through those REST APIs we talked about, or specific software development kits, SDKs, to make integration easier. The toolbox aims to provide basic building blocks for different ways of designing solutions, different architectural approaches.
Yeah.
And it's expected to grow over time.
Grow how?
By incorporating things from other European projects, from open source communities, from the CommuniCity partners themselves. Even the developers working on the open call projects can potentially contribute new components they create back to the toolbox.
Oh, cool. So it sounds like a collaborative and ever-growing set of resources. Very dynamic.
That's the idea.
And the sandbox. That's where the testing happens before anything goes live in a city, right?
Precisely. The Sandbox is a secure online environment. It's hosted in the EU, and it's where developers can check if their services, their applications, actually follow the CommuniCity specifications. It's meant to be a safe, reliable place to try things out, to experiment.
So developers can basically play around with the toolbox components, test their own code without any risk of messing up real city systems.
Exactly that. The Sandbox will let developers easily set up and run key toolbox components. They mentioned using pre-made recipes to make this easier.
Recipes. Right.
And they can also test how their solutions interact with other applications and external services. The main goals are make it easier to learn the toolbox, provide a safe place to test, and ultimately validate that everything meets the CommuniCity standards before deployment.
Okay, specifications set the rules, the toolbox gives you the instruments, and the sandbox is where you rehearse.
Got it. Now let's dig deeper into some of these key specifications and APIs. The document really highlights MIM1 NGSILD. You mentioned it earlier.
Yes, NGSILD. It's really central to how CommuniCity handles context information. It's an API standard.
An API?
For allowing systems to provide, consume, meaning access, and subscribe to context information. That's up-to-date information about digital representations of real-world things, often called digital twins.
Digital twins, right. Having a standard way to manage this kind of dynamic, real-time information is absolutely crucial for any services built within CommuniCity. Think of a digital twin as a virtual copy of something in the real world, like a traffic light, a building, an air quality sensor with real-time data associated with it.
So the virtual version of the physical world constantly updated. You mentioned NGSILD built on an earlier version, NGSI v2. What's the main difference? Why LD?
Good question. So NGSI v2 was the initial ETSI specification. It focused on things called entities, their attributes like temperature or status, and some metadata. NGSI LD built significantly on this.
How so?
It added much better support for linked data principles. That means understanding how different pieces of information relate to each other across systems. It uses property graphs, and technically it leverages JSON LD.
JSON LD, linked data.
Yeah, JSON LD allows you to embed semantics, the meaning of the data, right into the data structure itself using web concepts like URIs. This makes the data much richer and more understandable to different systems automatically. It helps break down silos at a deeper level.
So NGSILD can understand the connections between different bits of data more effectively, not just the data itself.
Precisely. In the NGSILD model, you have entities, the main things you're describing. These entities have properties, which are their characteristics, their attributes, and crucially, they can have relationships with other entities.
Relationships. How does that work?
These relationships use unique web addresses, URIs, to clearly identify and link to other entities. So you can explicitly say, this parking meter is located in this street, and both the parking meter and the street are identifiable entities. It's like building a web, a graph of interconnected data about the city.
He's building a web of knowledge about the city.
Right.
Broadly powerful. What about the structure of this NGSILD information model? Is it rigid?
It has structure, but it's designed to be flexible. The NGSILD information model has two main levels. First, there's the core meta model.
Core meta model.
This defines the basic structural elements that all NGSILD entities share. Things like their unique identifier, a URI, their type like building or air quality observed, general properties, and relationships. It's the common grammar.
Okay, the basic grammar.
Second, there's the cross-domain ontology. This provides specific, agreed-upon ways, schemas of describing common concepts that pop up everywhere, like time and geographical location.
Standard ways to talk about time and place. Makes sense.
Exactly. And then on top of this, you can create even more specific models for different domains like transportation or energy using standard web ontology technologies like OWL. So think of it like a basic framework with pre-made components for common things, plus room to define your specifics.
So a layered approach. Basic structure, common concepts, then domain specifics. What kind of actions can you actually perform with the NGSILD API? What operations are there?
The API specification includes different sets of operations. The core API handles the fundamental tasks of managing that context information, creating entities, updating their properties, retrieving data about them, deleting them, the basic CRUD operations for digital twins.
Create, read, update, delete, standard stuff.
Right. Then there's the temporal API. This deals specifically with the history of that information, how properties or relationships have changed over time. Super important for analysis.
Seeing trends, patterns.
Yeah. There's also the registry API. This manages information about where to find different sources of context data. It helps discover information providers. It also handles subscriptions and notifications, so an application can ask to be told automatically when certain data changes.
So you don't have to keep asking, is it updated yet?
Exactly.
Yeah.
And finally, there's the JSON LD context API, which handles the definitions, the vocabularies that make the data's meaning clear, managing those semantic contexts.
Okay, that sounds like a really complete set of tools for managing this real-time, interconnected city data. Moving on to MIM2 common data models. You mentioned the need for these. Why are they so critical again?
Right, MIM2. As we touched on earlier, really boils down to the basic need for common data models across different areas, different verticals, to really make applications and systems in different cities work together effectively. Interoperability again.
Right.
If City A describes traffic flow one way and City B describes it completely differently, then an application designed for City A just won't work in City B without major rework.
Yeah, makes sense. You need that shared understanding of what the data means.
Precisely. If they don't have a shared understanding of the data structure and semantics, smooth communication is just, it's not possible. It's like trying to have a conversation when you don't speak the same language or even the same dialect.
So what kind of existing data models and standards does CommuniCity suggest using for MIM2? Are they prescribing specific ones?
They point towards using data models that are compatible with NGSILD, which makes sense given MIM1. And they reference models coming from various initiatives we've already mentioned. OASC itself, FIWARE, GSMA, the mobile industry body, SynchroniCity's legacy, and of course the Smart Data Models Initiative repository.
So leveraging that big library.
Exactly. They also mention other existing ways of structuring data, other relevant standards. Things like Serif and 1M2M, which are common in the IoT world. Also core vocabularies from the European Commission's ISC program, Microsoft's Digital Twin Definition Language, DTDL, and even another MIM, MIM7 places, for spatial data, how we describe locations and geography accurately.
Wow, quite a list. The goal seems to be using existing, well-established models whenever possible.
Absolutely. It's all about building on what's already been learned, what's already been agreed upon in various communities. Avoid reinventing the wheel for describing common city concepts. Standardization is key.
Right, building on prior art data-wise. Now, MIM3TM forum specifications. That sounds a bit different from data models and context APIs. What's the focus there?
Yeah, MIM3 shifts gears slightly. It focuses on making it easy and secure to get access to local data sources, often through this idea of data marketplaces or data ecosystems.
Marketplaces again?
Right. The aim is to create standard ways for those who have data or services and those who need them to connect, discover each other, and potentially conduct transactions. It's about managing the exchange.
So, like a well-organized way to share, maybe even trade or license city data and services.
Essentially, yes. It's about the mechanisms for making data and services discoverable and accessible under defined terms. For implementing this, CommuniCity recommends using the TM Forum Open APIs.
TM Forum, that's a telecom standards body, right?
Primarily, yes, but their APIs are designed to be more general. These open APIs and the related sets of components they define are designed to work with different underlying technologies. They're technologically agnostic and provide the building blocks for creating those marketplace or ecosystem capabilities.
Okay. And why TM Forum? Are they widely used?
They are very widely used, especially in the telecommunications industry, but their applicability is broader. They're designed to be reusable, extensible. And importantly, their data models have also been harmonized to work well with FIWARE and GSMA models, so there's alignment there too.
Can you give me a few examples of these TM Forum open APIs that are particularly relevant for CommuniCity? The document probably lists some.
It does, yeah. Table 1 in the deliverable gives examples. There's the Product Catalog Management API that helps in listing what different providers offer, like data sets or analytics services. The Service Catalog Management API helps manage the specifics of those services.
Okay, listing what's on offer.
Then you have the Product Ordering Management API and Service Ordering Management API. These are for actually placing orders or requests for these products and services.
The transaction part.
Exactly. And they also have APIs for things like party management, keeping track of the different organizations and individuals involved, and customer management, which are obviously key for managing relationships in any ecosystem. That's just a sample, but it gives you an idea.
So these APIs provide the standard ways to handle the business logic side of data exchange, essentially. Discovery, ordering, managing who's involved.
Exactly right. They cover the life cycle from listing what's available to making deals to managing the relationships between the different players in the CommuniCity ecosystem.
Okay, that makes sense. The document also briefly touches on other specifications, relating them to the remaining MIMs, MIM4 and MIM5.
Yes, it does. It mentions that for MIM4, which is about personal data management, they're looking at specifications based on the My Data principles and approach. The key idea there is putting users firmly in control of their own personal data, ensuring transparency and user agency.
Empowering the citizen regarding their data.
Right. And for MIM5, which is still an area under active development globally focusing on fair AI, trustworthy algorithms CommuniCity plans to be actively involved, they'll be considering existing efforts like the algorithmic transparency standard being developed in places like the UK and Netherlands, and contributing to the ongoing OASC work on MIM5.
So they're not just implementing, they're actively participating in defining the future standards, especially around AI ethics.
That seems to be the intent, yes.
It really sounds like CommuniCity is trying to cover all the bases, not just the technical connections, but also the business logic, the ethical considerations, and the personal data aspects. Very comprehensive.
It aims to be, yeah.
Okay, let's switch our focus now more squarely onto the toolbox. You mentioned earlier it has reference implementations of the MIMs. What does that actually mean for someone using it, a developer?
Right, the reference implementations. So the first version of the toolbox will include working examples, actual software, showing how to implement MIM1, MIM2, and MIM3.
Concrete example.
Yes. For MIM1, they're including the Orion LD Context Broker. This is a mature piece of software from the FIWARE ecosystem. It supports both the latest NGSI LD standard and the older NGSI v2 for backward compatibility. And importantly, it's fully compliant with the newest official ETSI NGSI LD API specification. v1.3.1 at the time of the document. So developers can immediately start working with a key standard-compliant component for managing that real-time context data we talked about. It's ready to go.
So developers get a ready-to-use piece of the puzzle, the core engine for handling their context data. No need to build it from scratch.
Exactly. That's a huge head start. For MIM2, the Common Data Models, the Toolbox will use the Smart Data Models initiative as its main source, its baseline repository.
Using that library we discussed.
Right. They plan to select and include even more specific models based on what the cities and the developers in the open call projects actually need. So it will be a curated, relevant set.
A carefully chosen set of data blueprints tailored to the project's needs. And for MIM3, the marketplace aspect.
For MIM3, the Toolbox includes something called the Business API ecosystem. This is a reference implementation, an example of various TM Forum APIs working together.
An example marketplace.
Essentially, yeah. It provides the tools for managing, publishing, and even potentially monetizing different kinds of digital assets like data, algorithm services throughout their entire lifecycle.
So it's providing the fundamental software needed to actually use these MIMs in practice, not just the specifications.
That's the goal, yes,
Yeah.
to lower the barrier to entry.
Now, the Toolbox also offers software as a service, AI algorithms for image analysis. That sounds really interesting, very cutting edge.
It is pretty cool. The Toolbox will provide a set of pre-built AI algorithms specifically for analyzing images. Developers can access these capabilities through an API or a specific software development kit, an SDK.
And why image analysis specifically?
Well, it's partly to help bootstrap AI-powered applications that might come out of the open calls for projects. Many smart city use cases involve cameras and visual data. Initially, they'll offer a Python library with computer vision components that, importantly, use the NGS-ILD standard for exchanging data, so it integrates smoothly with MIM1.
Ah, so pre-built AI capabilities that developers can just plug into their own solutions, and they already speak the right data language.
Exactly. Makes it much easier to incorporate AI. They'll have a collection, a catalog of machine learning models that can be easily used. Plus, there will be predefined projects within the Toolbox.
Predefined projects.
Yeah, these combine some of these AI models to perform specific common tasks, like detecting objects in a video stream. And these projects will output the results as NGS-ILD data, using those agreed-upon common data models from MIM2.
So ready-made workflows almost.
Kind of. And these projects can be used on their own or integrated as components into larger applications.
What kind of image analysis can these algorithms actually do? Any examples?
The document mentions several, yeah, and even includes figures, which we can't show here, obviously. But they include instance segmentation,
Which is?
identifying and outlining individual objects within an image and classifying them like car, pedestrian, bicycle. Then there's pose estimation.
Like figuring out how someone is standing.
Exactly. Predicting the location of key points on a human body joints, mostly. Useful for activity recognition, for example. There's also age and gender detection from faces.
Okay.
And more advanced face recognition capabilities. This includes detecting faces, extracting unique features, and potentially identifying known faces.
Privacy implications there, but powerful tech.
Absolutely. That links back to the importance of MIM4 and MIM5. And finally, they mentioned emotion detection based on facial expressions, identifying things like happiness, sadness, anger.
Wow. That's a pretty impressive starting set of AI tools to offer developers right out of the box.
It is. It could significantly accelerate the development of certain types of smart city applications.
Definitely. How is this whole toolbox put together technically? How do developers access it?
There are a few ways. Primarily, the core Toolbox library, the code, will be available as a Git repository, like GitHub or GitLab. This gives developers complete control. They can fork it, modify it, see exactly how it works.
Standard open source approach.
Right. For those who want to get started more quickly or just use it as is, it will also be pre-installed and ready to run within the Sandbox environment.
Convenient.
And finally, key parts of it, especially the AI services, will be offered as a cloud service that you can access through a REST API. So you don't necessarily need to run the code yourself.
Multiple ways to get access, catering to different needs. What are some of the main modules or parts within the Toolbox code library itself?
The document shows a structure, Figure 21. The first version includes modules 4. Models, that's the AI models themselves. Structures defining basic ways to organize the output from the models. Context tools for interacting with the NGS-ILD context broker. Utils general helper functions, common utilities. Data models for creating and validating NGSI-LD data entities based on the standard models. Projects those predefined task implementations using the AI models. And visualization tools for seeing the data models or results in a more human, understandable way.
Seems pretty well organized, logical structure. And you mentioned each of these projects has its own online service or API.
Yes, that's right. Each project, like the face recognition one, has its own API service. These are built using the FastAPI Python framework, which is modern and efficient, and they're packaged using Docker containers.
Ah, Docker. That makes them easy to deploy and run anywhere, right?
Exactly. Very standard practice now. These APIs follow standard documentation formats like Swagger or OpenAPI, and they use a common format, JSON schema, for describing the data they expect and return, and for handling errors consistently.
Okay. And what can you do with these project APIs?
Typically, they allow clients other applications to upload images for analysis, get the results back, or even configure the service to automatically send the results, as in GSILD data, directly to a context broker.
Streamlining the data flow. Makes sense. What other helper services are included in the Toolbox ecosystem?
They're also providing a separate service specifically for uploading and downloading images. This can act as temporary storage needed by the AI projects during processing. And as mentioned, there will be a web-based interface, a front end,
A front end?
for visually exploring and testing the Toolbox components directly from a web browser. So you can try out the face detection, for example, without writing any code initially. Just upload a picture and see the results.
A nice way to see and interact with the tools visually, get a feel for them. How do all these different parts of the context broker, the AI services, the user applications, how do they communicate with each other? Is it all point to point?
They can operate point to point, but a key pattern they support is a more distributed, decoupled approach using that context broker as the central hub. It enables a producer-consumer pattern.
Producer-consumer.
Yeah. Some components act as producers of context data. For example, an AI service analyzes a video feed and produces information about detected pedestrians, sending it to the context broker. Other components act as consumers. They subscribe to specific types of information at the broker.
So an application interested in pedestrian counts would subscribe to that data?
Exactly. As soon as the producer sends new pedestrian data to the broker automatically notifies all subscribed consumers. They don't need to know about each other directly. The broker handles the distribution.
Ah, like a publish-subscribe system. Or like a newsfeed where some sources publish information and others subscribe to the topics they care about.
That's a great analogy. It makes the whole system much more flexible and scalable. You can add new producers or consumers without reconfiguring everything else.
Very neat. Okay, it sounds like a powerful and flexible system design. Now, let's dive into the sandbox itself. We know it's a testing environment, but what are its main goals officially?
Right, the sandbox. It has several key objectives outlined in the document. First, obviously, it needs to be a robust technical environment where the pilot projects can actually test their solutions in a setting that's realistic enough.
Okay, realistic testing.
Second, it's there explicitly to help and support these pilot projects during their setup phase and their testing activities. It's not just infrastructure, it's supported infrastructure.
Support is crucial.
Third, it needs to provide sufficient computational resources, CPU, memory, storage, for each pilot project to do what it needs to do without interference from others, ideally.
Having enough horsepower is critical, yeah. What else is important about the sandbox's purpose?
Another key goal is to make sure that each individual sandbox environment is a reasonably good replica, or at least representative, of a typical city's digital platform or infrastructure where these solutions would eventually be deployed in the real world.
So the testing is meaningful.
Exactly. And finally, maybe most importantly from a CommuniCity perspective, each sandbox must have the basic MIM-compliant components deployed and running. MIM1 and MIM2 are stated as the absolute minimum requirement for every sandbox instance.
So it's not just a generic cloud server, it's specifically pre-configured with the CommuniCity fundamentals built in.
Precisely. It's tailored for testing MIM-compliant smart city solutions.
Makes sense. Who are the main people who will actually use the sandbox, and what are the key parts that make up the overall sandbox system?
The document identifies two main groups of users. There's the operations team. They're the administrators, the ones responsible for managing the sandboxes, keeping them running. And then there are the pilot teams. These are the developers, the testers, the people building and validating the new solutions within the open calls.
Ops and devs, basically.
Kind of, yeah. And the key components of the overall system include Sandboxes themselves, which are typically planned as virtual machines with dedicated resources. There's a support system, likely a ticketing system, or help desk to handle questions, requests, and issues, and a community environment like a forum where users can discuss things, share knowledge, help each other out.
A support system and a place to connect with others. Yeah, those are really important for a smooth development process, especially in a multi-stakeholder project like this.
Definitely.
What are some of the typical things that the pilot teams, the developers, will need to do with the sandbox? What are their main interactions or use cases?
The document outlines several key use cases for the pilot teams. They'll need to be able to request a new sandbox instance for their project. They need to access their login information securely. Then, obviously, access the sandbox environment itself to install their software, run tests, etc. They might need to address. Request changes to their sandbox configuration later on, maybe more memory or disk space. And finally, when they're done, request the removal or decommissioning of their sandbox.
Makes sense, pretty much the standard life cycle of using a dedicated testing environment. What about the operations team's tasks? What are their main responsibilities?
The operations team naturally has the flip side of those tasks. They'll be in charge of actually creating, editing, modifying, and deleting sandboxes based on pilot requests. They need to monitor the performance and health of the sandboxes. They'll need to report on issues and work to resolve problems reported by the pilot teams via the support system. And they need to be able to send warnings or important notifications to users when necessary, like for planned maintenance.
So they're the administrators, the caretakers, and the first line of technical support for this whole testing setup.
Exactly. They keep the lights on and help the pilots succeed.
What are some of the key assumptions the project is making about the people who will be using the sandbox? What kind of background are they expecting?
That's covered too, Table 4. The document assumes that sandbox users, the pilot teams mainly, will have a basic technical background. They should be familiar with operating systems like Linux, comfortable using Secure Shell, SSH, to connect to remote computers, and have some experience working with Docker containers.
So not for complete beginners, but standard developer skills.
Right. It also assumes, as we said, that each sandbox will have at least MIM1 and MIM2 capabilities ready, that each sandbox is intended for a specific pilot project, not shared use, that the content inside data software is temporary and can be deleted after the project. And importantly, that everyone using the sandbox will agree to certain legal terms and conditions.
Standard procedure. Important ground rules for managing the testing space effectively and legally. Now, what about the requirements for the sandbox itself? How does it need to function?
The requirements are broken down into non-functional, the general qualities, and functional, the specific things it needs to do.
Okay, give me the highlights of the non-functional ones. How should it be?
Key non-functional requirements include the sandboxes must come pre-installed with those basic MIM1 and MIM2 compliant components. They need to be highly available, especially during the open call project periods, and ideally for some time afterwards. They must allow connection out to external services on the internet. Pilots need administrator-level access, root access, within their own sandbox. Each sandbox needs to be in an isolated network environment for security. They must support the deployment and use of the AI Toolbox components. And users must be notified promptly about any changes, like software updates, that might affect how they use the sandbox.
Sounds like they're aiming for a solid, dependable, secure, and usable testing platform. Makes sense. What about the specific things that the pilot teams need to be able to do with it, the functional requirements?
For pilot teams, the key functional requirements are pretty straightforward, reflecting those use cases. They need to be able to request a sandbox instance, access it, and then install and execute their applications within it. Request changes and adjustments to their sandbox setup if needed. Report issues and ask for help through the support system. And ideally, they should also be able to see performance metrics and resource usage history for their sandbox, and maybe even choose a specific type of sandbox based on pre-installed optional components when they first request it.
Give them some control and visibility. And what about the operations team? What specific functions do they need to have available?
The operations team must be able to create, modify, delete, and possibly archive sandboxes, respond to support requests from pilots, have the ability to delete or significantly change a sandbox if there's a critical security or technical issue, reallocate computing resources between sandboxes if necessary, though dedicated resources are preferred, and communicate effectively with the pilot teams. Ideally, they should also have a central dashboard to monitor the overall status and resource usage of all the sandboxes under their management.
So the tools they need to manage the whole fleet of sandboxes efficiently. It sounds like a well-thought-out system, at least on paper. What's the overall plan for actually building and implementing this sandbox environment?
The proposed sandbox solution involves creating some new software components specifically for management. They mention a sandbox manager for handling the creation, modification, deletion lifecycle, a sandbox monitor for tracking usage, availability, performance, and a user interface, probably web-based, for facilitating communication and requests between the pilot teams and the operations team, likely integrating with that support ticketing system.
Okay, custom tools for managing it?
Yes, but they also acknowledge that the initial implementation, the first version, will probably involve a fair amount of manual steps by the operations team, supported by existing tools like the ticketing system, before everything is fully automated.
A practical, phased approach, starting with the essential elements and manual processes, then automating more over time. Makes sense. What are the core software components that will be inside a basic sandbox instance? What comes pre-installed?
Figure 28 in the document shows the internal components. A basic standard sandbox will include a Lion LD, that NGSI LD context broker we keep mentioning, Timescale DB, which is a specialized database based on PostgreSQL, but optimized for time series data. Very useful for IoT sensor readings and historical context. Mintaka, another component, likely for querying that temporal NGSILD data stored in Timescale DB efficiently. Docker, to allow pilots to easily run their own containerized applications. And of course, the CommuniCity Toolbox itself, pre-installed.
So the core MI1, Orion LD, Mintaka, Timescale, and Toolbox components are there by default.
Exactly. Those are the mandatory green components in the diagram. They also mention optional yellow components that might be included, like standard SQL or NoSQL databases, Redis for caching or faster data access, and Grafana for creating dashboards to visualize data from Timescale GB or other sources. And some other components were evaluated, but perhaps not chosen for the base image.
A strong foundation with potential for adding more tools if needed. How do the pilots actually get into their assigned sandbox? What's the access mechanism?
The plan is that each sandbox is set up as a virtual machine running within a secure environment, likely a private cloud or data center, which has controlled internet access. Pilots receive special access credentials, probably SSH keys. They first connect through a secure virtual private network, VPN, to the data center network. They mentioned Porto Digital in Portugal as the likely location. Once on the VPN, they can then use a standard secure shell SSH client to log into their specific sandbox virtual machine using the credentials provided to them.
Okay, so a standard secure two-step process. VPN first, then SSH into their dedicated machine. Seems reasonable. What about the crucial computing resources, CPU, RAM, disk? How is that handled?
That's a key consideration. The plan is for each sandbox to be given its own dedicated guaranteed resources, a certain amount of processing power, vCPUs, storage space, disk, and memory, RAM. The exact amounts were still being decided when the document was written, but the principle is exclusivity.
Dedicated resources are good, avoids the noisy neighbor problem.
Exactly. However, they are also considering different scenarios for managing these resources, especially if demand is high. One option is giving each pilot a fixed quota that's always available. Another is potentially using a scheduling system, maybe calendar-based, if many pilots need peak resources simultaneously, although dedicated is preferred.
What about specialized resources like GPUs for AI?
Good point. They explicitly mentioned considering the provision of graphics processing units, GPUs, which are often needed for training or running demanding AI models from the toolbox. Because GPUs are expensive and often in high demand, access to these will likely be managed on a scheduled, calendar-based system rather than being permanently assigned to each sandbox.
Makes sense. Share the expensive toys.
Right.
Managing those resources efficiently and fairly is definitely going to be key to the sandbox's success. Finally, what kind of support and community features will be available for sandbox users beyond just the technical ops team?
Besides the direct help desk ticketing system for technical issues with the operations team, the project plans to create an online community forum.
A forum for
all CommuniCity participants, pilots, city representatives, partners to share knowledge, exchange ideas, discuss challenges, and find solutions together. Peer-to-peer support and collaboration.
building a community around the project.
Exactly. The requirements listed for this forum, Table 8, include things like allowing authorized users to join, Having moderators to oversee discussions, letting people post messages and reply to threads organized by topics or categories, having user profiles, and including a search function to find relevant information easily.
Standard forum features. Do they mention any specific technology for it?
They mention MyBB as a potential open-source forum technology they might use.
Okay. A platform for people to connect, collaborate, and get help from each other. It sounds like CommuniCity is really thinking about not just the core technology itself, but also the ecosystem and the support system needed around it to make it successful.
That seems to be the goal, yes. Building the tech and the community together.
So after this really quite deep dive into the technical foundations, the architecture, the tools, what's the main benefit for you, the listener? What should you take away?
Well, hopefully you now have a much clearer picture of the technical underpinnings of the CommuniCity project. You can see the layers, the specifications, the tools, the testing ground, and maybe you have a better sense of its potential to be a major driver of innovation in smart cities.
Absolutely. The key things that really stand out to me are the central role of interoperability, working together through those OASC MIMs. It's not just tech for tech's sake.
Right. Standardization is crucial.
Then there are the practical tools and even those quite advanced AI capabilities offered by the CommuniCity Toolbox, real stuff developers can use.
Lowering the barrier to entry.
And finally, the dedicated MIM-compliant testing environment provided by the Sandbox, complete with support. It reduces the risk for developers trying new things.
And all of this, taken together, points towards a future where creating and deploying new solutions for the complex challenges our cities face becomes, hopefully, more standardized, more efficient, and much more of a collaborative effort across different cities and stakeholders.
So here's a final thought, a provocative one maybe, for you to consider. How might these standardized specifications, these shared resources, like the Toolbox and Sandbox, how might they accelerate the creation and deployment of your own innovative solutions for the urban problems you care about?
Yeah, think about the possibilities for collaboration, for faster development, for potentially applying your ideas not just in one city, but across many that adopt these standards.
If you want to keep exploring this, where should people look next?
Well, as we've mentioned, the OASC website is the place to go for more details on the MIMs themselves. The FIWARE catalog online will show you the range of generic enabler components that are available. And the Smart Data Models Initiative website is great for understanding the common ways of describing data in this whole smart city space.
Great pointers. Encourage you to continue the journey.
Definitely.
That's all the time we have for this deep dive into CommuniCity's technical architecture. Until our next exploration, keep thinking big about our cities.